so for this one, they're talking about the intermediate value theorem. So the first thing that you want to do is you want to note that f of x can be defined as 8 sine of x minus x. And then showing that it has a solution is the same thing as showing that f of x has a 0. So the first step is you define f of x as this function where everything is moved over to one side. Now, if you define f of x in that way, this function is continuous because it does not have a denominator, it doesn't have a square root, or any sort of piecewise function. So it is continuous on pi over 2 to pi. Okay, so that's the first step of the intermediate value theorem. So this again is our proof here. Now, the second step is that you need to show that there is a sign change in f of x over this interval. So you'll plug in pi over 2 into f, and here is where you need your unit circle. So if you look on your unit circle at pi over 2, you're at 0, 1, and your sign coordinate would be 1. So this is going to become a 1, so you will have 8 times 1, so just 8 minus pi over 2. Okay? Now, your other function evaluation will happen at f of pi, and that will give you 8 times sine of pi minus pi. And again, if you look on your unit circle, at pi, you have negative 1, 0. So your sign is going to evaluate to 0. You have 8 times 0 minus pi, so that just gives you negative pi. So this is clearly negative. If you were to get a common denominator here for the 8 minus pi over 2, that evaluates to be a positive because you have approximately 8 minus 3.14 over 2. So there is a sign change in your function evaluations. So you then, the third step, you write up your conclusion. So by the intermediate value theorem, there exists a solution in the interval, the open interval, pi over 2 to pi.